that while it's going. Okay. So sum means add, difference means subtract. But because this is inside of a trigonometric functions, they don't follow necessarily all of the same rules that we're used to. So like if you do cosine of A minus B is inside, that is not the same as cosine of A minus cosine of B. You can't like undistribute from inside of the function because it's not multiplication, it's a function itself, right? So we have these different identities that we can use for doing that. So for example, if you had A was 1/2 is pi over 2 and B was 0, then A minus B is equal to cosine of pi over 2 minus 0, right? Right? And what's the cosine of pi over 2? What's the cosine of pi over 2? 0. Yes, 0, which is 0, right? However, if you had split it across, this would be the cosine of pi over 2 minus the cosine of 0, which is 0 minus 1, which is negative 1. Right, because the cosine of 0 is 1. So this is why we can easily disprove using order of operations that you always have to do inside the parentheses first. Okay, so we can't split it like that. So this is kind of why we have these different identities, that it's going to be a little weird and it's going to be another thing that you're going to have to memorize. Okay, the sum and difference identities. So instead of splitting it across, we have this identity that if you have cosine of something plus something, okay, and we'll go over the proof on Monday, but if you have the cosine of something that is equal to cosine of A times cosine of B minus sine of A times sine of B. Okay, so if it's addition, it's cosines multiplied together of the two separate things minus sines of the two separate things. If it's adding, it's subtraction. So if it's subtraction, it's going to be the same thing, just with addition inside. So cosine of A times cosine of B plus sine of A times sine of B.
Have any equations that will end up as a number without letters?
No, not anymore. There'll be equations that involve numbers, but not that are solely numbers. You got a lot of letters. So one of the reasons why we care about this is why can't we just do the inside stuff first, right? Pi over 2 minus 0 was just pi over 2. So then we could just do cosine of pi over 2. So all of this originates from pre-calculator land. Okay, so before calculators, because you can type into your calculator cosine of anything minus anything inside, and it does the inside first, right? Cosine of 90 minus 45 is just the cosine of 45, right? So with those key points, we can know those off the top of our head. This is also where the unit circle comes in handy. But what happens if you end up with something like cosine of 15? Is 15 degrees on our unit circle? No. Can we just say, well, that's half a 30? No. Nope. So we'll talk about that next week. We talk about the halving stuff. But how could we rewrite 15 as either addition or subtraction with the angles that we know from our unit circle? 45 minus 30. Okay. So cosine of 15 degrees is cosine of 45 minus 30. Okay, so our 45 is A and 30 is B. So now we just need to put it into our difference identity. So this will end up being the cosine of 45 times the cosine of 30 plus the sine of 45 times the sine of 30. Okay, because your calculator will just give you a decimal. It won't give you the exact mathematical answer for these ones. And that's what we want, is we want the exact with all of the square roots and rationalized denominators and everything. Yeah. No, no, because that would be if you did addition and then negative, which is gonna, the odd even stuff messes with it. Yeah, because it's already taking care of the fact that this is subtraction by flipping that sign. Okay. But that's a good question. All right, what is the cosine of 45? Right, that's pi over 4. Root 2 over 2. What is the cosine of 30? Root 3 over 2. Plus, what is the sine of 45? Root 2 over 2. And what is the sine of 30? 1/2. Okay, so we have root 2 over 2 times root 3 over 2 plus root 2 over 2 times 1/2. What is root 2 over 2 times root 3 over 2?
6 over 4.
Root 6 over 4. Multiply straight across the top. And root 2 times over 2 times 1/2. Root 2 over 4. So then how can we simplify this even further? We can add together. Can we actually add 6 plus 2 and say that's the square root of 8? If this was 18, it would be. But 6 is just 3 times 2. There's no buddies, right? There's no identical twins. So you can't simplify either of these. But we can combine it because they have the same denominator. We can rewrite it like that. Okay. Let's see if we can make this a little smaller so I can scooch that underneath. All right, what about cosine of 5 pi over 12? Do we have any pi over 12s? No, we have pi over 3s and we have pi over 6s, right? So take a minute, see if you can work with your partner, figure out what either addition or subtraction of some combination of over 3s and over 6s would get you into 12s. Or, yeah, so 5 pi over 12 is the same, as pi over 6 plus pi over 4. Okay, so you kind of uncommon denominator, right? 5 pi over 12 is pi over 2 minus 1/12, right? Because that would be 6 pi over 12, right? So you're minus 1/12. So you have a total of 5/12, and you have some combination of either 4 plus 1, which 1/12 doesn't get us into something that we have, or 3 plus 2. Well, 3/12 is pi over 6, and 2/12 is pi over 4. Yeah, or 3 is the 6 and 2 is the, yeah. So you can kind of think of it as 5 is 1 plus 4 or 3 plus 2. Well, the 1 doesn't help us get into 4, 6s, or 3s for our denominators from our unit circle, but the 3 and 2 simplified too. Right. All right. So now that we have this in addition, we need to put it into our formula. So our A is pi over 6 and our B is pi over 4. So we have the cosine of pi over 6 times the cosine of pi over 4. And is this going to be addition or subtraction in the middle? Subtraction. It's the opposite, yeah. Times sine of pi over 6 times sine of pi over 4. They do, because now we're actually finding the cosine of pi over 6 times the cosine of pi over 4. So what's the cosine of pi over 6? Root 3 over 2. right? Because pi over 6 is 30 degrees. And then what's cosine of pi over 4? Root 2 over 2. Minus sine of pi over 6 is 1/2 times sine of pi over 2 is root 2 over 2. So we end up with the same numbers. We have root 6 over 4 minus root 2 over 2. There's just subtraction in there instead. Should be a 4. And that is our mathematical answer. But if you were to type this into a calculator, it's just going to give you a decimal. Right? It won't give you the actual mathematical, which the decimals are always a rounded version. What is 5 pi over 12 in terms of degrees? Is it if you have pi over 6 plus pi over 4? So you have 30 plus 45 is 75 degrees, right? Which the reference angle for 75 degrees could also be 15. It's 15 short of 90. So we get that kind of relationship of the same but subtraction. Not quite terrible. This is a lot of just straight calculations. But take a look at C. What's different about C? They're all angles that are bad. They're not necessarily bad. They're just not as friendly, right? We don't know the cosine of 87 off the top of our head. So in this case, if we have this expression, what does it kind of look like? It looks like the addition one, right? So this looks like cosine of A plus B. What is 87 plus 93? 180, right? Which is cosine of 180, also known as pi, which is what? Well, the radian is pi, but what's the cosine? The radian is pi, but what's the cosine of pi? -1. So that gets us to -1. But I want you to try something. In your calculator, put your calculator in degree mode, and then type in this whole big thing, cosine of 87 times cosine of 93 minus sine of 87 times sine of 93. See if you get exactly -1 in your calculator. Try that.
Oh, it's already in.
All right, so these calculators, at least the yellow ones in the classroom, are a little bit smart. They give you -1, but that didn't used to be the case. And as little as 10 years ago, if you put that in the calculator, it would round all of the values so much that it would give you like -0.99999. It wouldn't recognize that it was like the opposites and they added to -1. All right, so co-function identities, when we have those 90 relationships, right? If you have cosine of 90 minus something, right? So we said that 75 was 90 minus 15, right? What is that the same value as? Right? Or like 30 degrees, the sine of 30 degrees is the same as what other one, right? Sine of 30 is 1/2. What other degree has something that's a 1/2? Cosine of 60 is 1/2. I don't know if I phrased that well, but the cosine of 60 is 1/2, and that's the same as the sine of 30. And they add up to 90, right? So cosine of something that added up to 90 is the same as the sine of that angle. Right? We talked about this a little bit back at the beginning of the semester. Right? But if they add up to 90, you can replace like cosine of 30 is the same as sine of 60. So you can know it, hey, if it's asking for something that I know the other one, you can replace them. But they have to add up to 90. Right? And same thing with sine is cosine of 90 minus that angle. So sine of 15 degrees is the same as cosine of 75 degrees. And same thing with cotangents, also have that same relationship. And tangents, my pen is dying. And then secant and cosecant, they all have that same relationship with the buddies. Yeah.
Bad tangent if we didn't have a budget and lines and stuff.
So one of the ways that we can use this is cotangent of what is exactly equal to the tangent of 25.
Tangent,
Yeah, so that'd be 90 minus 25 equals tangent of 25. So the cotangent of 65 is equal to the tangent of 25. Right? So theta in this case would need to be 65 degrees if you're plugging it into the cotangent, or 25 degrees if you're plugging it into tangent. And you would get the same numerical value out. Right? Which cotangent is 1 over tangent, right? So this also means that 1 over the tangent of 65 is equal to the tangent of 25. You can test that in your calculator. If you put 1 over tangent of 65 and then tangent of 25, you should get the same numbers. All right, take a look at B. Sine of what is equal to cosine of negative 30? Mm-hmm. 120? It is 120. So sine of 90 minus negative 30 is equal to cosine of negative 30. So sine of 120 is equal to the cosine of negative 30. And that also takes care of any negatives along the way, right? Because sine of 120 is going to be a positive number because it's a y coordinate in quadrant 2. And the cosine of negative 30 is a x coordinate in quadrant 4, which is also positive. So the positive negative signs, you don't even have to think about the quadrants when you do it this way. As opposed to reference angles, which you do have to think about the positive and negatives. One, two. All right, try number C on your own and check your answer with a buddy. All right, check your answer. Remember 90 in radians is pi over 2. So cosecant of 3 pi over 4 is the secant of 90 minus 3 pi over 4, which is negative pi over 4. Or negative 45 degrees. All right. I do want to get through at least these identities so that you can get started on the homework. Even if we don't get to do some of the examples today, but I want to make sure that you have all the formulas that you need, okay? So for sine of things that are added together, it's going to be a little bit different, okay? For cosine, it is cosine times cosine and then plus or minus sine times sine, and it's just the opposite plus or minus from what the inside was, right? So cosines and then sines separated by the opposite sign of what was inside. But for sine, it's a little bit different. It is sine of A times cosine of B plus the sine stays the same plus the cosine, come here, cosine of A times the sine of B. Okay, so sine A cosine B plus cosine A sine B. So it's AB, but instead of cosine, it's sine, cosine, cosine, sine. And then it's the same positive, negative that you see inside. The good news is that you'll have these for your homework. And then for subtraction, it's the same sine, cosine, cosine, sine with just subtraction in the middle instead. So sine of A times cosine of B minus cosine of A times sine of B. And then tangent is where it gets a little fun. Okay, and we'll go over the like where these all came from next week as well. And then for tangent, this one's the weird one. So you have tangent of A plus tangent of B over 1 minus tangent of A times tangent of B. They're like a puzzle. And then for subtraction, your positive and negatives flip spots. So then this is tangent of A minus tangent of B over 1 plus tangent of A times tangent of B. Okay, and that's where this video is going to end because we have to get ready to go.